Hi, everyone, and welcome to this Women on Stage International Women's Day conference. Today, I'm going to be talking about observability for resilience in distributed systems and just showing you how you can navigate complexity and enhance stability. I believe that the most difficult part of software engineering is maintaining a live system and maintaining high availability. I'll give you an example. As a user, imagine if Instagram was down on Christmas Day and you couldn't post your favorite pajama picture. How would you feel? Now, let's think about what this actually means for businesses. Um, there's a 2023 annual outage analysis done by Uptime Institute, and it says that over two-thirds of outages cost companies more than $100,000, indicating a sustained increase compared to the previous years. And the report emphasizes the growing impact of human error and management failures and outages. There also cost estimates. The median cost of outages with high business impacts is $7.75 million. Nearly a third of outages costed companies at least $500,000 per hour. Now, what can we take away from this? Outages remain financially detrimental for companies, with costs potentially reaching millions of dollars per incident. The impact significantly varies depending on industry, company size, and outage duration. Applications need to be resilient for great user experience and for business continuity as well. It's not just for the business and it's not just for the user, because we've seen now that outages affect the user and outages can also affect the business. And either way, it's not a good look. So it's important for us to have and build resilient systems. And in this talk, what I'm going to be doing is showing you how engineering teams tackle this problem. But before we get right into it, I would want to quickly introduce myself. Hi, my name is Adora, and I am a software engineer. I'm also the founder of Nexa Skill, an edtech nonprofit currently helping people start and scale their careers by connecting them to opportunities for stimulated work experience. I'm an award-winning tech woman. I've been recognized in different countries. I've been recognized in Nigeria, Dubai, the US, Ghana, Tanzania, Ivory Coast, and more. I'm an author of three cloud engineering books, and I've spoken at over 150 plus conferences worldwide. I'm a DJ, I'm a content creator, and I've been featured on Tech About, Business Day, Logitech, CIO Media, Tech Points, This Day, Punch, and more. So let's get started with this conversation. And the first thing I want to say is that resilience is crucial in distributed systems. And when you actually think of the sort of like the similarities, or rather the connection between resilience and observability, you would see what I'm talking about in the context of that, because observability gives you the ability to monitor applications, while resilience is the fact that the applications are available, the applications don't have errors or don't have issues and things like that. And to get to a state where your applications don't have these issues or don't have them as frequently as they should have them, you have to constantly monitor and learn from that, right? So when you're building out distributed systems, resilience is something that is very important. And when we're thinking about the resilience framework, there's so many things. There's replication and redundancy. Building resilient applications, might require you to replicate your data centers, your infrastructure, so that there are multiple instances. And if one instance in one data center is down, requests can route to another instance, via using load balancers and things like that. But that's just one part of it. There's also, the ability to have fault tolerant systems. There's chaos engineering, there's failure detection and recovery, and there's monitoring and observability, which is exactly what we're going to be talking about today. And I know that I sort of touched on this already, but just, reiterating again that observability is the ability to measure a system's current state based on the data it generates. So, with the logs, the metrics, the traces, and all the other data that the system generates. Observability is the ability to measure the state of that current system and just sort of understand how that system is doing. That helps you make more informed decisions when it comes to the system, the availability, and its resilience generally. And observability also helps you increase resilience and availability of a system. So, now going back into the connection between resilience and observability, we can see that observability is something that helps in, you know, increasing resilience. If you're trying to build resilient systems, you want to make sure that you are gathering information about those systems so that you learn more about the systems and you make them better over time so that they are more available, they're stronger, they are more resilient, they are faster, they provide an overall great experience for users. And how does observability actually for resilience? Let's think about it. Um, the first thing is early detection and diagnosis. When you have observability hooked up in your system, you are monitoring the system, you are sort of, monitoring the data, and you just sort of understand what's happening within the system. You can detect errors early enough. You can run root cause analysis on errors that you find and fix issues from the very root of the problem, because now you have data to make informed decisions as to why certain things in your system sort of happened the way they did. You can have adaptive responses to issues that come your way. And continuous improvement is also something that is very important. In the context of software engineering, there's always the opportunity to learn from the current design. There's always the opportunity to learn from the current technology. And in this context, continuous improvement is also not left behind. So you can improve on your systems to make it better, to make it more optimal, and sort of grow from there. I'm going to talk about a few practices for observability because I think that they are very, very, very important. The first one is logging, the next one is identifying and collecting metrics, the third one is tracing, and then there's alerting, anomaly detection, incident response, cross team collaboration, as well as continuous improvement, like I just spoke about. Now, logging involves the process of recording, different events, activities, and messages that are typically generated by the application during the operation. So you can log regular information that just helps you understand the application when you're trying to look through the execution path. You can log warnings, you can log errors. There are different levels for logging. And this helps whoever is troubleshooting later go through the logs and understand how the system was behaving. It's a way to record system behavior, essentially. And logs can be used in the context of observability to help people understand what's happening in the system, and what happens when you make API calls, when you make these method calls, and how the system is flowing, and the things that sort of like flow, tracking various aspects of the system and things like that. Metrics are quantitative measures, and they provide insights into performance, health, and behavior of a system. So in the context of metrics, right, you would be tracking things like CPU utilization, you would be tracking latency, you would be tracking throughput, you would be tracking reliability, maybe in the 90th percentile, in the 95th percentile. You want to know um different things around how many, let's say I sent 1,000 requests, how many requests actually failed, how many requests succeeded, how reliable is my system, all these kinds of things. These are the typical quantitative measures that metrics track, and they help you understand, the health of the system, the performance of the system. But in the context of logs, logs are more around events that take place when the system is in operation, right? So, for example, in the context of logs, let's say it's an e-commerce website, and when you click on an add cart button, the a log is emitted somewhere that says, okay, this item got added to the cart, this item got added to the cart, this item got checked out, this item was paid and it was successful, or this item was attempted for payment but it failed. Those are logs. That's data that you can look at and sort of understand, oh, the user probably tried to call XYZ and then they failed. But metrics are different. They're around the health of the system. And metrics help track various aspects of a system, such as resource utilization, response time, error rates, and other key performance indicators. They are used for monitoring system health and identifying trends over time. Now, tracing is different. And remember when I was talking about observability, I talked about logs, metrics, and traces. Tracing involves capturing and recording the flow of requests as they traverse through different components or services in the system. Distributed training helps visualize the journey of a request, enabling the identification of bottlenecks, latency issues, and dependencies between different components. Alerting is the practice of setting up notifications or alarms based on predefined conditions or thresholds to notify operators or teams of potential issues. Alerts are designed to bring to attention the abnormal or critical solutions, allowing teams to respond promptly and address issues before they impact the user experience. So typically, when a problem is happening in the service, when the system is having issues, the teams should have alerts hooked up, and these alerts help notify whoever is on call to know that, okay, there is a problem. The alerts, and most people use different kinds of tools for their alerts. You can get a phone call, you can get paged, you can get an email notification, but there are different ways to sort of bring that incident to your attention so that you know that you are supposed to go and fix exactly whatever the incident is about. The next thing is anomaly detection. Anomaly detection also involves identifying patterns or behaviors that deviate from the expected or normal behavior of a system. And in anomaly detection, you can use statistical analysis to sort of highlight unusual patterns in metrics or in behaviors. And this can help teams identify potential issues or security threats so that they can proactively fix all of these issues. One thing I want you to note is that I'm talking about these different things in the context of observability, and we're seeing how basically data is being collected, data is being analyzed, and that is being used to sort of look at the way the system works and make the system better, whether in a proactive or in a reactive way. So just so that we understand how important observability is when building software. It's not just about building the application and shipping it. It's also about constantly making sure that that application stays resilient when it is deployed. And the way to do that is to have different methods and mechanisms for running observability. The next thing is incident response, and this works hand in hand with alerts. So when an incident is found, when there's a new incident, an alert is triggered. When an alert is triggered, what the user, or rather what the engineer that got the alert needs to do is what you would call incident response. An incident response is a set of procedures that are taken by a team in response to an unplanned event or a service disruption. Incident response aims to minimize the impact of incidents, restore services to normal operation, and learn from the incidents to prevent similar occurrences in the future. So typically when there is an incident, the user, or the on-call engineer, or the entire team needs to wake up and fix that incident. But it's not just only about fixing the incident. It's also about learning from that experience and sort of making your application in such a way that that incident doesn't happen again and affect your users. The next thing is collaboration, which is very important even beyond this conversation of observability and building resilient systems. If you are in any team, you need to collaborate. And This is essentially about promoting cooperation and communication between these different teams. And in the context of, incident response and observability and alerting and things like that, collaboration ensures that teams work together seamlessly, share responsibilities, and leverage each other's expertise to achieve common goals. Next thing I want to talk about is continuous improvement, because when you think about an incident and you fix that incident and you write postmortems, which are, documentations that you typically write after an incident, talking about what's happened and, why it happened and things like that. In the process of doing that, you sort of have to do a root cause analysis to understand what the root cause of that incident was. And then you can also declare steps to make sure that that particular root cause, the thing that caused the problem, is something that you can completely resolve so that that incident doesn't happen again. And all of these things happen in continuous improvement. It's an ongoing process, and it's a process of refining and enhancing your systems, your processes, and your practices based on the feedback and the lessons you learn from being on call generally. Continuous improvement aims to iteratively enhance the efficiency, reliability, and resilience of systems. It involves regular assessments, retrospectives, and the implementation of changes to adapt to evolving requirements and challenges. Now, I want to talk about being on call. What an on call schedule is, what does it actually mean? I'm sure we've heard it before. Oh, I'm the on call engineer right now, I'm on call. But what does this actually mean to be on call? On call schedules are a practice where people take turns being available outside of regular work hours to respond to incidents, alerts, and emergencies related to the system's operation. The on call schedule ensures that there is always someone available 24/7 to address critical issues that may arise even during non business hours, weekends, or holidays. Like I said, imagine if Instagram is down on Christmas Day. How would you feel? Even on Christmas Day, there is someone that is on standby on call just in case something happens that goes into the system and fixes what needs to be fixed. So, it's very common practice for people to take turns and be available to make sure that the system is always up and the users are not affected. So now let's talk about what typically happens in an on-call schedule. The first thing is that your shift starts, and once you are on your shift, you are sort of just like monitoring different incidents. And when the first incident comes in, if there's an incident, the first thing is that the alert is triggered, and then the on-call engineer acknowledges that alert and begins to investigate and troubleshoot the issues. Most teams typically have something called a troubleshooting guide that allows people to go through the different kinds of incidents that can exist and know what to do in certain kinds of incidents, right? So there's a guide for, if it's this kind of incident, this is what you do. If it's this kind of incident, this is what you do. Sometimes, yes, what the kind of incident that you come across might be a special incident that you've probably never seen, and in that context a troubleshooting guide might not help you. But one thing that is very good in healthy engineering teams is, even though you are done solving the problem for that incident that you were exposed to, even if there was no troubleshooting guide, definitely write one, because there's a possibility that someone else might see that incident or something similar in the near future, and your experience could help them navigate it. Regardless, throughout the troubleshooting process, it's important to communicate and consistently share your ideas. It's important to communicate, share your ideas, share your findings, share your observations publicly, so that people are aware that this is the current state of the incident, this is what is happening. And if you need to escalate it to somebody in higher power, maybe because of permissions that you don't have, or any other kind of reason that might cause for an escalation, or the incident is actually beyond you or beyond your team or beyond your experience and you need to escalate to somebody else, then you can do that. Um, Once you've successfully investigated and figured out what the issue is, and you're constantly communicating, because communicating doesn't stop, it's ongoing. The next thing is to figure out a mitigation strategy, is to actually find a way to mitigate the incident as quick as possible, because because you want to reduce the impacts that this incident has on your customer. A mitigation might not be a final resolution, right? um and you might mitigate that issue temporarily, just for the sake of making sure that the customer isn't blocked. But then an actual resolution to that problem might take a couple of days, right? But at least there's a quick fix right now that works to solve the problem that the incident creates. And after that, that's when you do post incident analysis, you do your post-mortems, you do your root cause analysis, you do all of those things, and you go for the next incident. You sort of like repeat the cycle until your shift ends and you hand over to whoever is supposed to be taking over after you. Now, let's talk about monitoring, which are two key parts of, or rather, proactive and reactive monitoring, which are two key parts of observability. And we've sort of hinted that, but I just want to make it clear, right? Proactive monitoring focuses on identifying and addressing issues before they impact the user experience or system performance. It involves actively monitoring, analyzing systems data to anticipate problems and take preventive actions. And proactive monitoring is early detection, preventive measures, automation. So in terms of monitoring, you think of like running automated tests, or running a heartbeat check periodically to be sure that the health of the system is still in check. That's doing things proactively, right? But then reactive monitoring is more around responding to issues when they occur. So proactive tries to, you know, address these potential issues before they become a thing, but reactive monitoring is more responding to issues as they occur, focusing on diagnosing and resolving problems that have already impacted the system or the user experience. And that's typically where incident response comes in. So when there is a new incident, regardless of the importance or the severity of the incident, right? You want to make sure that you address those incidents. And incident response is reactive because you are reacting to something, you are reacting to the incident. Post incident analysis is as a result of an incident that has just been closed or completed. So that's also part of the reactive, framework, as well as manual intervention, because something wasn't right in the system that automated tools couldn't fix, and somebody had to go into the system to make sure that it was fixed manually. That's also pretty reactive. And I'm just going to give a lot more examples about that. So with proactive monitoring, it's regular performance testing to identify potential issues before they impact users. Is implementing auto scaling based on predicted traffic patterns to ensure optimal resource allocation. And it's using anomaly detection algorithms to identify trends that might lead to issues, and identifying them in advance and combating them before they become an issue. While in reactive monitoring, it's around addressing a sudden spike in error rates reported by monitoring systems, responding to alerts triggered by performance thresholds being breached, and investigating and resolving user reported issues in real time. So that's reactive monitoring. There are so many tools that people use for observability today. Some of those tools are, people using Elastic, Logstash, and Kibana. Some people use Datadog. Many people use PagerDuty for um, getting paged and receiving alerts. And different companies can also have like internal tools that they use for their observability as well. So there are tools that you can use to hook up to your already existing tech stack that sort of helps you manage your systems better and be more proactive, and also reactive, to make sure that you fix a bunch of all these issues. I wouldn't choose proactive monitoring over reactive monitoring. I think they are both important, and they should be in everybody's, observability plan for building their own resilient distributed systems. Thank you for attending this conference and sort of listening to this talk. I hope that you've learned something new about observability and what it is if you didn't know it before. The goal of this talk was to give you a very high level theoretical breakdown as to what it is. And if you are interested in learning it, there are a few more links that could help you here, and they are on the screen. I hope that these things are useful to you, and I hope you enjoy every other talk from every other speaker. Thank you and enjoy the rest of your day. Bye.